Today we are going to do lessons 10 and 11. Both of these lessons are looking at domain and range. Another way to think about this is input and output. So if we look at the first question, it says the cost for an upcoming field trip is $30 per student. The cost of the field trip, capital C, in dollars, is a function of the number of students, X. So what you want to remember, go back to earlier in Unit 4, and remember that when we saw the words is a function of, the very next thing was our input, which means what comes before it is our output. So now that we know what the output is and what the input is, this question wants us to select all the possible outputs for the function defined by c of x equals 30x. So we have to think about this in context. Our input, x, is the number of students. Now what we know about students is that this number for x must be a whole number. I can't have partial students on the field trip. So if a whole number must go in for x, then that means the output must be a whole number times 30, which means all outputs must be multiples of 30. So 20 is not a multiple of 30, so it's not A. 30 would be 30 times 1, so one student on the field trip. That is a possibility. 50 is not a multiple of 30, so that could not be an output. 90 is 30 times 3, so if there were 3 students, that could be an output. And 100 is not a multiple of 30. So for the first question, answers B and D are the only correct choices because they are multiples of 30. A rectangle has an area of 24 centimeters squared. Function f gives the length of the rectangle in centimeters when the width is w centimeters. So remember, when you see the words function gives, the very next thing is your output. So my output is the length of the rectangle, which means the width is my input. Determine if each value in centimeters is a possible input of the function. So they want to know if these numbered values could be the width. So we need to understand that the area of a rectangle is length times width. So 3 times 8 equals 24. So 3 could be the width if the length is 8. 0.5 times 48 equals 24. So the width could be 0.5 if the length was 48. So that is a possible input. 48 could be the width if the length is 0.5, because 48 times 0.5 is 24. So that is a third possible input value. Now, -6 would mean we have a width of a rectangle that is negative. And it is physically impossible to have a negative length of a rectangle, because then you would not have a rectangle. So -6 cannot be an answer. And finally, 0. If there is no width, then there is no rectangle. So 0 also could not be a width of the rectangle. So anytime you are trying to determine what numbers could be inputs or outputs, you need to think about the context of the problem. Think about what type of numbers could or could not be inputs and outputs based on the context. In this problem, we know we have a rectangle, therefore we must have a width, therefore the width cannot be 0, and it cannot be negative numbers. Select all the possible input-output pairs for the function y equals x to the third power. Remember, the first number in our pairs is always x, and the second number in our pairs is always y. So in order for this to be an input-output pair, we would need to be able to take the x value, cube it, which means multiply it by itself 3 times, and get the y value as the output. So for A, -1 times -1 equals 1, times -1 equals -1, and -1 is our y value, so A is a possible solution. For B, -2 times -2 equals 4, and 4 times -2 equals -8. Our y value was 8, therefore this is not correct. For C, 3 times 3 is 9, and 9 times 3 is 27. 27 is not 9, so C is not correct. D, we have 1/2 times 1/2 equals 1/4, and 1/4 times 1/2 equals 1/8, and that was the y value, therefore D is correct. E, we have 4 times 4 equals 16, and 16 times 4 equals 64, which is the y value, therefore E is correct. And finally, F, 1 times 1 equals 1, and 1 times 1 equals 1, but the y value was -1. That does not match, so F is not a correct answer. A small bus charges $3.50 per person for a ride from the train station to a concert. The bus will run if at least 3 people take it and cannot fit more than 10 people. Function B gives the amount of money that the bus operator earns when N people ride the bus. Identify all numbers that make sense as inputs and outputs for this function. So we can see that our input is people riding the bus. And there must be at least 3 people and cannot fit more than 10 people. So the input is whole numbers because you cannot have partial people. And that is between 3 people at the least and 10 people at the most. You can see that the output is the earnings in dollars. And that's $3.50 per person. So the smallest amount that could be charged is $3.50 times 3. 3 times 0 is 0. 3 times 5 is 15. Carry the 1. Bring down the decimal. 3 times 3 is 9. Plus 1 is 10. So the smallest amount that could be charged is $10.50. And the largest amount would be $3.50 times 10 people, because you cannot fit more than 10 people on the bus. 1 times 0 is 0. Bring down our decimal. 1 times 5 is 5. And 1 times 3 is 3. So my output is multiples of $3.50 between $10.50 and $35. And then number 2 wants us to sketch a graph of B. So our first point would be at 3 people, $10.50. Then 4 people would be $14. 5 people would be $17.50. 6 people would be $21. 7 people would be $24.50. 8 people would be $28. 9 people would be $31.50. And 10 people would be $35. We don't have any points before 3 because we cannot have less than 3 people. And we don't have any points after 10 because we cannot have more than 10 people. And we do not connect these points because the money is charged per person. So we cannot have a money amount that is not a multiple of $3.50. So for this context, we would only have the points within that domain of people and that range of prices, nothing in between and nothing before or after. Two functions are defined by the equations f of x equals 5 minus 0.2x and g of x equals 0.2 times x plus 5. Select all statements that are true about the functions. A says f of 3 is greater than 0. So if we substitute 3 in for x, we have 5 minus 0.2 times 3, negative 0.2 times 3 is negative 0.6, and 5 minus 0.6 is 4.4. 4.4 is greater than 0, so A is a correct answer. B says f of 3 is greater than 5. Well, we just found f of 3 and said it was 4.4. 4.4 is not greater than 5, so B is not a correct answer. C says g of negative 1 equals 0.8. So we can take negative 1 and substitute it in for x. So we have 0.2 times negative 1 plus 5. Negative 1 plus 5 is 4. And 0.2 times 4 is 0.8. 0.8 does equal 0.8. So C is a correct answer. D says g of negative 1 is less than f of negative 1. We already know g of negative 1 equals 0.8, but we need to find f of negative 1. So we're going to substitute negative 1 in for x. We have 5 minus 0.2 times negative 1. Negative 0.2 times negative 1 is positive 0.2. And 5 plus 0.2 is 5.2. Now if we compare, 0.8 is less than 5.2, so D is correct. And finally, E says f of 0 equals g of 0. So we need to substitute 0 in for x in both functions and compare the results. 5 minus 0.2 times 0. Anything times 0 is 0, so that answer is 5. Then we have 0.2 times 0 plus 5. 0 plus anything is itself. So 0.2 times 5. And 0.2 times 5 is 1. 5 does not equal 1, so E is not a correct answer. The graph of function f passes through the coordinate points 0, 3, and 4, 6. Use function notation to write the information each point gives us about the function. Remember that in a coordinate pair, the first number is x and the second number is y. And remember that when we write function notation, f of x equals y. So when we use function notation, we have f of 0 equals 3, and we have f of 4 equals 6. The x values go in parentheses, and the functions equal the y values. Match each feature of the graph with the corresponding coordinate point. If the feature does not exist, choose none. A wants us to find the maximum. The maximum is the highest point on the graph in reference to the y value. That would be this point on the graph, and our coordinates there are 4, 16. So A matches with 3. B wants the minimum. The minimum is the lowest point on the graph. We find that at the bottom of this valley here, where the value is x equals 1.5 and y equals 2. So B, the minimum, matches choice number 2. C wants the vertical intercept. The vertical intercept is the point at which the graph touches the y-axis. And we see that right here in orange, where x is 0 and y is 7. So C matches choice number 1. And finally, D wants the horizontal intercept, which is the point where the graph crosses the x-axis, and we can see that our graph never goes all the way down to the x-axis. So D would match with choice 4. The graphs show the audience in millions of 2 TV shows as a function of the episode number. For each show, pick 2 episode numbers between which the function has a negative average rate of change, if possible. Estimate the average rate of change or explain why it is not possible. So we have show A and show C. For show A, we go up, up again, up, 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 up. We stay the same, up, and up. So for show A, it's not possible because the viewers never decrease. Now, for show C, we see that we go up a little bit, down a little bit, up a little bit, up a lot. Then we come back down, 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 and stay the same. So we could pick any 2 episodes where it goes down, I'm going to use the largest, which is right here, from episode 5 to episode 6. So show C decreases between episodes 5 and 6. And if we look at episode 5, we're between 5 and 6 million, so we could say 5.5 million. We decrease down here to about 4 million. So we decreased about 1.5 million in one episode. So we could say show C decreases between episodes 5 and 6 by approximately 1.5 million viewers. And this is the last question for lesson 10. Now we will move on to the practice questions for lesson 11. Again, this lesson is about domain and range, where domain refers to the possible numbers that could be inputs, and range refers to the possible numbers that could be outputs. A child tosses a baseball up into the air. On its way down, it gets caught in a tree for several seconds before falling back down to the ground. Select the best description of the range of this function. So what you want to remember is that your range is your output. That is your Y values. So if we look, we do see it start at 5 and go up to 12.5. But we also see it come all the way back down to the ground where it's 0. So the range is everything from the lowest point when it hits the ground at 0 to the highest point at 12.5. And we need to think about the context. This range is measured by height in feet. It is possible to have partial feet. That ball is going to hit every measurement on the way up and every measurement on the way down. That's why this has a solid line. So while choice B is correct that it's between 0 and 12.5, it says all integers. And integers are the counting numbers, 1, 2, 3, 4, 5. We're saying we can have all those numbers in between, so we want choice D. The range includes all numbers from 0 to 12.5. To raise funds for a trip, members of a high school math club are holding a game night in the gym. They sell tickets at $5 per person. The gym holds a maximum of 250 people. The amount of money raised is a function of the number of tickets sold. Which statement accurately describes the domain of the function? So first we need to know they want domain, and domain means input. Then we need to remember when we see the words is a function of, the very next thing is the input. So the input is the number of tickets sold. So now we need to think, what kind of numbers could possibly be tickets sold when the gym holds a maximum of 250? A says all numbers less than 250. Well, we cannot sell partial tickets, and the gym can hold a maximum of 250, so it would not only be numbers less than 250. B says all integers. That would include negative numbers, and you cannot sell negative tickets, and it would include numbers larger than 250, but the gym cannot hold more than 250 people. So B is not a correct choice. C says all positive integers, but that would include numbers above 250 all the way to infinity. The gym has a maximum of 250. So C cannot be correct. Choice D says all positive integers, which we want, less than or equal to 250. That would be the correct description for the domain of this function. Function C gives the cost in dollars of a cafeteria meal plan as a function of the number of meals purchased, n. The function is represented by the equation C of n equals 4 plus 3n. Find a value of n such that C of n equals 31 is true. So, if we know that C of n equals 4 plus 3n, and we know C of n equals 31, then we can set these equal to each other. Our goal is to get n by itself. So first we get rid of the 4 by subtracting 4 from both sides. This gives us 3n equals 27. And now we get rid of the 3 by dividing both sides by 3, and we get n equals 9. So the value of n that makes C of n equal 31 is 9. And part 2, what does that value of n tell you about the cafeteria meal plan? N equals 9 tells us 9 meals purchased equals $31. Lynn completes a 5K using a combination of walking and running. Here are 4 graphs that represent 4 possible situations. Each graph shows the distance in meters as a function of time in minutes. Match each description with a graph that could represent it. A. Lynn starts out running, but then slows down to a jog. After 10 minutes, she stops for a water break. She then runs the rest of the way. So we want her to start running, then jogging. So graph 4, this portion would be running. Then we would have jogging, then stopping, and finally running. So A matches graph 4. B says Lynn starts the race walking, gradually getting faster and faster. This would be graph 3. We have walking, then we have faster and faster as the graph gets steeper and steeper. So B is graph 3. C says Lynn jogs at a steady pace for the entire race. This would be graph 1. This never changes. So this is a steady pace. It doesn't get steeper. It doesn't get flatter. It goes up at the same rate the entire time. So C matches graph 1. And lastly, Lynn starts out walking, then moves to a steady run. After 15 minutes, she stops to stretch a cramped leg. Then she walks the rest of the way. So here we have walking, then running. Then here we have her stopped, and finally walking again. The steeper the incline, the faster she's going. So D matches graph 2. The graph of H shows the height in meters of a rocket t seconds after it was launched. Number 1. Find H of 0. What does this value represent? Well, the number in parentheses is my x value. So when x is 0, our line touches the y-axis at about 15 meters. What does this value represent? Starting height of the rocket. Number 2. Describe the domain of this function. Your domain are the possible inputs. So domain will be your x values. We see that the domain starts when x is 0, and we see that it ends when x is approximately 4.5. So the domain of this function is all numbers between 0 and 4.5. Number 3. Describe the range of this function. Remember that your range is your output values, your y values. We see that the lowest y value is 0 when the rocket lands, and it's approximately 35 meters when the rocket is at its high point. So our range would be all numbers between 0 and 35. And number 4, solve h of x equals 0. Well, a function equals its y value. So if we look, y is 0 down here at the end when x is approximately 4.5. So x equals 4.5. What does this value represent? This value represents the time when the rocket lands. Mai has to decide between two cafeteria meal plans. Under Plan A, each meal costs $2.50. Under Plan B, 1 month of meals costs $30. Number 1, write an equation for function A which gives the cost in dollars of buying N meals under Plan A. So for number 1, we could call it function A of an unknown number of meals equals $2.50 times the number of meals. Number 2, write an equation for function B which gives the cost in dollars of buying N meals under Plan B. So this time we would call it B of N, and it is a flat rate of $30. So we would just say that it equals 30. And number 3, Mai estimates that she'll buy 15 meals per month. Which meal plan should she choose? Explain your reasoning. Well, A of 15 equals $2.50 times 15 meals, which is $37 B of 15 equals $30 because it is a flat rate that does not depend on the number of meals. So now if we compare, Plan B is $30, Plan A is $37.50. So $37.50 is greater than 30. That means A of 15 is greater than B of 15. So she should choose Plan B because it is $7.50 cheaper. So this is all the practice problems on the worksheet for today. If you have any questions regarding domain and range, please use class time to ask for clarification. This material could be on the end of Unit 4 test.